Hello friends, you have reached part 5 in a series of tutorials about Chromia and Rell. Good job so far. In the previous episode we coded an operation for creating a player, and in this one we will call this code from the command line. Copy this code to the my.rel dApp project like we did in episode 3. We don't want to test all code, since Cursor for sure made a lot of mistakes. It's time to use the CHR tool again, which we installed in part 3. Since we made changes to the code and since we used the --wipe flag, the blockchain RAD will change, so copy it from the logs. In production we never wipe the database. Instead, the original blockchain RID will remain even after we make changes to the dApp. Open a new terminal window. To test our code we first need a key pair. The CHR tool has a command called keygen, where we also can specify the location of the file containing the keys. If we look into the secret file, we'll just see the private and the public keys. The private key we don't show anybody, and the public key is our identity. Initially, the blockchain is empty, so if we use the query command and call the getPlayers query, we expect to get no player. Note that we don't have to specify the key pair for queries. To add a player, we must use the tx command, short for transaction. Here we must specify the key pair, or else the transaction won't be signed. We use \quote to wrap a string here. When you build a transaction this way, look at the documentation to understand how to encode the various data types. Now, when we issue the same query again, we get a response, a 1. But what does that mean? We remember that the query returned a full player entity, but let's look in the database to see what we got. Okay, we go into the database. We find the schema via \dn. We set the schema with set search path. Then we can look in the tables with \dt. And finally, in the player table, we see that the only column with the value 1 is the row ID, which is our primary key. That's the key that was returned. The getPlayerNames query will return all the names, and in the getPlayerByName query, we provide an argument, the name we look for. Note that the argument syntax differ between transactions and queries. We also put some requirements in the operation. Can we test those? What happens if we create a new player with the name Pelle? You can pause here and think about it. We created a requirement that said that there could not be two players with the same signer. This requirement will be violated since we are using the same secret. Okay, but what happens if we simply don't sign our transaction? You can pause here to think. In this case, there will be no signatures in the list returned from the getSigners method. And when we try to fetch from position 0 in an empty list, we get out of bounds error. It's good to remember that submitting a transaction to a blockchain is an asynchronous thing, meaning we don't really notice if the transaction failed, because the nodes in the network will initially simply receive the transaction. Failure usually happens when the next block is built and the transaction is executed. The reason we see the error message is that CHR simply waits for the next block and fetches the status of our transaction. In episode 6 we will do joins. That's why you're here, right? Ciao!